Okay, so the first thing I want to graph is the tangent, whoops, excuse me, the tangent of 2 theta. So if we're going to graph that, the first thing we have to know is our angle is 2 theta. And we know our angle cannot equal pi over 2. And I'm also going to write on here that our angle cannot equal negative pi over 2. Now I could put 3 pi over 2 there because it's also undefined there, but I use pi over 2 and negative pi over 2 because those two kind of surround the origin. So if I know that my angle can't be pi over 2, that means theta cannot equal pi over 4. And I got that by dividing both sides by 2. And on this one, I know that theta cannot equal negative pi over 4. So now that we have the places where our tangent is undefined, we can graph it. So the first thing I'm going to do is graph pi over 4, and then I'm going to graph negative pi over 4, and those are where my vertical asymptotes are going to be. We know in the middle of these vertical asymptotes I'm going to get 0, and then we know tangent starts low and ends up in the first quadrant, has to be positive. Now that is going to be my tangent wave right there. And of course it repeats over and over and over again. Okay, let's try another example. So if we had 2 tangent of, let's say, theta over 2, and we wanted to graph that. Well, we know that our angle, which is, our angle, which is right here, cannot equal pi over 2, and my angle cannot equal negative pi over 2. So if I solve this by multiplying both sides by 2, I know that theta will not be able to equal pi, and down here I'll get theta will not be able to equal negative pi. So with that, now we're going to come over here and graph this, knowing that I'm going to have an asymptote at pi and negative pi. In the middle of my 2 asymptotes, I'll be at 0. And then I'm going to start low and end high again, like tangent always does. The only difference on this one now is that we have this 2 right here. And so what does that 2 do? Well, it's not an amplitude as much as it is a stretch, like it used to be a stretch when you graphed y equals x squared. So what's going to happen with that 2 is right in the middle of my asymptote and my 0, I'm going to be up 2 units. And over here, I'll be down 2 units right in the middle. And then that kind of defines my tangent wave. Okay, let's try one more. Let's try y equals 3 tangent. Let's do 2 theta, and then let's do 3 theta. And then let's put a minus 1 there. So right here, that looks really bad. Let me fix that. This right here is my angle. And so I'm going to have to set my angle equal to pi over 2 so I can find it where it can't be. And then I'm going to set my angle so that it can't equal negative pi over 2. If I solve for theta here, I'll find my asymptote to be at pi over 6, and it can't equal negative pi over 6. So when I go to graph this one, I'll have pi over 6 and negative pi over 6 for my asymptotes. Right in the mid, and then this thing is shifted down 1 also. So down here at negative 1, my center line will drop down 1. And so in the middle of my asymptotes, I will start at 0, but on the center line. This amplitude, this vertical stretch is a 3. So I'm going to go from the center here up 1, 2, 3, and then I'll be in the middle. And then I will go down 3 and be in the middle. And then there's my real stretched tangent wave right there. And that's how we graph tangent.